Okay, so with this question, sorry, hello, we're talking about related rates again, right? So let's start with this question. A boy on a skateboard rolls away from a lamppost at a speed of 3 feet per second. The light is 15 feet above the ground. The boy's height on the skateboard is 6 feet. So what we have so far is there is this lamppost. Nope, I need to draw. There is this lamppost, right, with a light that's on the ground. And then there is a guy on a skateboard and he's skating around. And he's rolling away from the lamppost at a speed of 3 feet per second. The light is 15 feet above the ground. So we're taking this to be 15 feet, and we're taking the boy's speed to be, it said 3 or 5? 3 feet per second. Okay, so we can kind of immediately tell we're going to be saying something about triangles, right? Well, this says at what rate is his shadow lengthening, right? So his shadow is going to be so far, right? And that's just going to be made by how the light is angled at him right there. So his shadow is going to be from here to here, and his distance is going to be from there to there. So we have kind of two triangles here. We have this triangle that the boy on his skateboard is the height of, which this says is 6 feet in the problem, right? The boy's height on the skateboard is 6 feet. And then we have the length of his shadow on the ground, right? Now this, because this angle is the same in the small triangle and the big triangle, actually tell us that we have two similar triangles. So the ratio of 15 over this side is going to be equal to the ratio of 6 over whatever that shadow length is going to be. So the thing to do now is try to figure out some expression that we can make from here. Well, in order to do this, let's actually give this side length a name. So the distance from the lamppost to the boy, let's say, is d, right? And that's changing with respect to time. But then we also have a distance from the tip of the shadow to the boy. And let's call that s of t, right? That should change over time as well. Well, that means that this entire length of the large triangle should be s of t plus d of t, right? The entire length should be the sum of the two individual pieces that we wrote. So it turns out the ratio that we have is it's the height of this lamp over the total bottom length, which we just said is s plus d, so s of t plus d of t is equal to 6 over the length of that smaller triangle, which is that variable that we called s, or that function that we're calling s of t. So it might actually be nicer to put the functions on top, right? So this ratio is supposed to hold, so it holds either direction. So let's go ahead and flip this so that the functions are on top instead, right? So now if I take the derivative of each side, well, we're dividing by 15, so that's just going to hang out. And on the right-hand side, we're dividing by 6, so that's going to hang out. The derivative of s plus d of t Well, the derivative just splits up across addition, so this is just s prime of t plus d prime of t. And this is equal to 1/6. And again, derivative of s of t times 1/6 should just be s prime of t. So the thing that we are looking for is how fast the length of the shadow is changing, which is exactly s prime. So the only unknown now is d prime. However, d prime is given to us in the question. He is moving away from the lamppost at a rate of 3 feet per second. So d prime of t is 3. So we have 1 over 15 times s prime of t plus 3 is equal to 1 over 6 times s prime of t. So now this is just a matter of solving for s prime of t. Well, we can go ahead and distribute this 1 over 15 to both parts. I kind of pulled it out. I never really needed to. Um, but this is s prime of t over 15 plus 3 over 15 is equal to 1/6. Or we can even write this as s prime over 6, right? Now we can move this 3 over 15 to one side. S prime of t over 15 minus s prime of t over 6 is equal to negative 3 over 15. So in order to add these, we need a common denominator. What's the smallest or least common denominator for 15 and 6? That would be 30. So this is going to be 2 s prime of t over 30 minus 5 s prime of t over 30. So 2 minus 5 is negative 3 s prime of t over 30, which turns into negative 1/10. So negative s prime of t over 10 is equal to negative 3 over 15. So now multiply both sides by 10. Well, sorry, negative 10. So s prime of t is negative 3/15 times negative 10. Well, negative times a negative is a positive. 3 times 10 is 30. And 30 over 15 is just 2. So all of that to say that this is changing at a rate of 2, and this is a length feet per second. Very good. So all of that to say the shadow is increasing at a rate of 2 feet per second. Now the last part of this question says at what rate is the tip of his shadow moving? And with that, that's really asking, right, what is the rate that this end of this point is moving, right? So what is the rate that this entire line is moving? Well, if this line really is s plus d, then taking the derivative of this line should be s prime of t plus d prime of t. So we just found s prime to be 2, and the question tells us d prime is 3, so that should be 5 feet per second. Very nice. So this problem ends up not being too bad as long as we make the very important recognition that these are similar triangles that are sitting inside of each other. Okay, very good. Okay, now let's talk about this classic problem. A particle moves along the curve y equals sine of pi x over 2. As the particle passes through the point 1/3, 1, its x-coordinate increases at a rate of the square root of 10 centimeters per second. How fast is the distance from the particle to the original, I think that's meant to be origin, changing at this instant? So something very subtle is happening here. Let me clear out this. Do not save. Okay. So something really subtle is happening here. So if we look at the graph that it's telling you of this point, it's going to look something like this, right? Well, it tells us that we have, right, y equals, is it 2 sine? Yeah, 2 sine of pi times x over 2. 2 sine of pi times x over 2. Really, we don't care like what the divide by 2 part is, so I'm just going to simplify this just the tiniest bit by just writing pi over 2 times x. Okay, so that is the path that the particle is taking. But we need to be very, 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 very precise with how we're saying this. That is the path that the particle is taking. That is not telling you anything about how it's moving in regards to speed, right? Because x is still its own function. Y of t, its position after t, whatever it is, I think minutes, right, is a function 2 times sine of pi over 2 in terms of x after a given time. So that's the thing to be careful is that there are two kind of functions that are simultaneously at play here, x of t and y of t. However, we end up being able to write y of t in terms of x of t. So it ends up not being too horribly messy. But we kind of have to, be careful about that, right? There is an x value that is telling you its speed, and then the y coordinate that is the y position at that given time, x. So it tells us that at the coordinate, or when it passes through the coordinate 1/3, comma 1, the x speed, how does it phrase it? Its x coordinate increases at a rate of root 10 centimeters per second. So the x coordinate is having that speed, which really means x prime of 1/3, right? Because that's the, sorry, nope. X prime of t at whatever moment gives us 1/3, right? X of that time is 1/3. Y at that time is 1. That's what this coordinate means. And at that time, the x-coordinate is changing at a rate of square root 10 centimeters per second, right? And then they ask how fast is the distance from the particle to the origin changing at this instant. So it wants to know the change in speed of the distance from the origin to whatever it is at that coordinate. Well, in order to find the distance from the origin at any of our points, right? That's going to be this line. So what kind of equation can I make, or what kind of shape can I make that can help me find this distance? Well, I recognize that if I just go straight down, then I have a right triangle where the length of this triangle is the x value and the height of this triangle is the y value, right? So really we have a Pythagorean theorem situation where x of t squared, nope, not equal to, plus y of t squared is equal to distance in terms of t squared, right? Just a squared plus b squared is equal to c squared. but with my functions plugged in here. Now, we might think for a second, oh, well, my x is 1/3 and my y is 1, so do I just take this derivative? And I have to tell you no, because if we plug that in, we're kind of pretending that instead of a function, we have a constant value, right? Because when we take this derivative, this would go to 0 plus 0. But it is not true that there is no change happening for our x and y, right? So we need to take this derivative with our chain rule. So again, this is 2 times x of t, x prime of t, plus 2 times y of t. Derivative of the inside is y prime of t. And then 2 d of t, d prime of t. And I ran out of room. I already like scooted it over, so actually, let me do this. 2 d of t, d prime of t. Great. Let me erase some of the extra part of this graph so that I can fit that all in one line. And wonderful. Okay. Now, we just need to figure out each of these pieces. We need, right, the thing that we're trying to solve for is d prime. So we need d of t, y prime of t, y of t, x prime of t, and x of t. Well, it tells us our coordinate, so we know x and y of t, right? Now it's safe to plug in those values. So this is 2 times 1/3 and 2 times 1. Now x prime, it tells us at this time x, the x coordinate is changing at a rate of square root of 10 centimeters per second. So my x prime is square root of 10. Now I need to figure out y prime. However, I have a function in terms of y, so now I can take the derivative of this and do y prime of t. Now we're multiplying by 2, so that constant multiple just hangs out front. Now we want the derivative of the sine thing, and we need to use the chain rule. So the derivative of the outside, the derivative of sine is cosine. We leave the inside alone, and then multiply by the derivative of the inside. Well, the constant multiple comes along for the ride, and derivative of x in terms of t is x prime of t. Okay? So, y prime at that moment that we're considering, we have 2 cosine of pi over 2. The x value is 1/3, and x prime at that moment is the square root of 10. So we can simplify this, right? I have pi over 2 here, and then times 2, so that's going to simplify to pi. The square root of 10, nothing crazy is going to happen with that. And now we want the cosine, right? We're multiplying by cosine of pi. 2 times 3 is 6, so pi over 6. And pi over 6 should be root 3 over 2. So this is pi times the square root of 10 times the square root of 3 over 2. So now we figured out what y prime is at that moment. So going back up here, we plug that thing in for y prime. Pi times root 10 times root 3 over 2. Pi times root 10 times root 3 over 2. And this is 2 times the distance at that time times d prime at that time. Well, can we figure out the distance at that moment? And I'd say yes, right? Because our Pythagorean theorem right? If we just want to know d of t at that moment, then we need our x of t and our y of t. But we know y of t is 1, x of t is 1/3, so d squared, right, at that moment is equal to 1/3 squared plus 1 squared. So 1/3 squared is 1/9. 1 squared is 1. So this should be 10/9, right? Because 1 is 9/9. So 9 plus 1 is 10. So d of t should be the square root of 10/9. So root 10/3. Very good. So all together at this moment, I'm going to combine some of this multiplication. 2 times root 10/3 plus 2 times 1 is nothing. This 2 gets multiplied by this, or divided by this 2. So that's just going to be pi root 10 root 3 is equal to 2 times this quantity we just found, root 10/3, times d prime of t naught. Well, we just figured out what everything except for d prime is, so all we have to do is divide both sides by this 2 root 10/3. So we notice, right, this term is exactly this term, so something divided by itself should just turn into 1. So we don't have to think too crazy about that piece. This part just goes to 1. Now dividing by 10, right, sorry, this root 10 should cancel with this root 10. So we're going to have pi root 3 over, or sorry, pi root 3 times the reciprocal of whatever's left after we got rid of that root 10. So that would be 3 halves is equal to d prime of t naught. And at this moment, this is kind of the nicest that we can write it. Okay, very good. This is a number. I can add 1 to these things. That is just some number, some horribly gross value that I don't think we really care too much to write down any nicer than that, right? Um, pi times the square root of 3 by itself is gross. Multiply by 3 halves and add 1. Sure, we can do that. That is some number. But anyway, that is the rate at which the distance is changing at that coordinate. Very good. Actually, to do one more thing to fix this last answer, we do all this, and then we need to say the units, and the question gave this, and centimeters per second was the only unit we got, so that is going to be the same thing here for us, centimeters per second, right? Okay, so now that should be our answer. Wonderful, very good. So this question tells us air is being pumped into a spherical balloon so that its volume increases at a rate of 50 cubic centimeters per second. How fast is the radius of the balloon increasing? And the diameter is 30 centimeters. So essentially, we have, right, a sphere, a balloon, right? It's not this flat circle, it is round. Uh, it's not a great sphere, but I think we get the idea. And we're talking about the volume here. So it is useful to remember or look up. If we're on the exam, hopefully remember if it's not given to us. But we need to remember the volume formula for a sphere. And that is 4/3 pi times the radius cubed. Is there a way to remember that? Take the derivative. The 3 up here will cancel the 3 you're dividing by. 4 pi r squared. It looks like the area, but multiplying, no, that doesn't really make sense at all. No, I don't think there's a good way to remember it. I was really hoping I could connect it to something else, but I kind of can't. not without learning a good bit more about calculus. Uh, Regardless, this is our volume. Well, this is changing, right? So in our case, it's more accurate to say that volume is a function of time and our pieces, you know, 4/3 and pi are staying the same, but our radius is increasing. So as a function of time, v of t is 4/3 pi r of t cubed. Well, now we take this derivative, and 4/3 and pi are both constant, so they just stick around. And then we do the chain rule, right? On the outside, we're cubing a function, so the derivative of the outside turns into 3 times the inside squared, and the derivative of the inside is r prime of t. Okay. However, the question tells us, right, air is being pumped into a spherical balloon so that its volume increases at a rate of 50 cubic centimeters per second. So it tells us the derivative is 50 the whole way through. Okay, so what is it asking for? How fast is the radius of the balloon increasing when the diameter is 30 centimeters? So can we see what it's looking for in our equation? Yes, it tells us it wants the change of the radius, so r prime. Well, what is the last unknown then in this equation? If I have 50 is equal to this equation, well, I still need to figure out what r of t. Well, hold on a second. It tells us how fast is the radius of the balloon increasing when the diameter is 30 centimeters. So if the diameter is 30 centimeters, right, d at that given time is 30 centimeters, well, that just tells us that our radius at that time is 15 centimeters, right? Half the diameter. So we have 50 is equal to 4/3 pi 3 times r at that time squared times r prime at that time. But again, we just figured out that that value is 13. So we have 4/3 pi 3 times 15 squared r prime of t naught. Okay, so we're going to divide by 3, right, thanks to this part of the fraction, and then multiply by 3, so those are going to cancel. So we have 4 pi 15 squared r prime of t naught is equal to 50. So really we just want to divide both sides by this chunk. 50 over 4 pi 15 squared is equal to r prime of t naught. And technically, these are all numbers, so in a sense we're done. Yeah, we really do want to know what 15 squared is. Um, I can never keep that straight in my head. Let's just do it to the side, why not? 5 times 5 is 25. 70, 1, 1, 2, 25. I know 25 times 25 is 625. So, anyway, that doesn't matter. 50 over 4 pi times 225. Well, I can go ahead and multiply this by 4. 5 times 4 is 20. 4 times 2 is 8, plus the 2 up there. We're going to add a 1 up there. 4 times 2 is 8, with a 9 goes to 900. So 50 over 900 pi. Um, we can cancel, you know, a 50 from the 900, right? 50 times what gives me 900? 50 goes into 90 once. Sorry, why did I do it that way? No, no, yeah, that's fine. 50 goes into 90 once, and it leaves 40 over, and then our 0 comes down. 50 times what gives me 400? Dun, 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 dun. 80, sorry, 8, 8, just 8, right? 5 times what gives me 48. So this goes in there evenly, just like we hoped. So this turns out that 50 times 18 gives me 900, so this does cancel, and this is 1 over 18 pi. That is my r prime at that moment, how fast the radius is changing. What are the units? Well, this is in centimeters and seconds, so this should be right because the radius is a distance that's centimeters per second. Wonderful. So this is the last question that I'm doing in front of us for the videos, at least over these things. Congratulations, you did it. You made it through 2 videos of related rates and numerous classroom time lectures of related rates. So good job. I'm proud of you. Uh, Now study this, get ready for the exam. Yay!